Alright, welcome back guys. This will be the last video for this lesson 5.1. In the previous videos, we introduced probability distribution, the definition, notation, several examples, and talk about parameters for probability distributions. Those are mean, median, mean, variance, and standard deviations. Kind of show you guys how to use the formulas, but if you don't want to do that, preferably not. We want to use technology. I think the last video I discussed how to use technology, and doing Zoom meeting, I can show you guys how to do this on Zoom as well. Not Zoom, on StatCrunch. It's very similar, but that's what we've done in the previous videos. I'm gonna go ahead and erase this part here so I have room for the next part in my notes. Just like the what we learned in chapter 3 when we introduced mean median for distributions given data set, and we were able to use that information through range rule of thumb to identify data values that are extremely large or significantly high or significantly low. That's through the range rule of thumb. Similarly, we can do the same thing for probability distribution as well. Given a procedure and given a x values, can we determine if it's possible? Is it significantly high, or is it unusual high or not, or is it unlikely to obtain such things? So we can apply the range rule of thumb in this chapter as well. So just briefly, just to recall the range rule of thumb, we have the mean in the middle, right? And then we have 1 2 standard deviation above the mean, and then 2 standard deviation below the mean, and any values that fall within the 2 standard deviation of the mean, it is considered to be usual value. So we say usual values, or not significant. Okay, in this case, past that would be significant, significant high, or significant low. Okay, but when it comes to probability, it's more fitting to ask the question, is it, it's more fitting to ask questions such as, is it likely or is it unlikely to, obtain, x equal to something, for a certain procedure. Right, so that question is more fitting than anything. Why? Because when it comes to probability, we want to look at what's the chance of obtaining certain values, and that is more a fitting questions. And in chapter 4, we define what probability value is considered to be likely or unlikely, right? So recall we defined that, for unlikely probability value, we gotta have p of x less than or equal to, so between 0 and less than or equal to 0.5 or 5%, right? So that was from the chapter 4 definitions. So let's look at that through this example here. We're given a table, right? We're given x and p of x. This is a probability distribution describe, the numbers of adults that are sleepwalkers among any groups of 5. Okay, so the study already been done, and we already got the probability given to us. We just gotta use the table to answer the question. Part A is asking for what is the probability of getting exactly 4 sleepwalkers among 5 adults. So this is saying that what would be the chance, any randomly group of 5 adults, what would be the chance exactly 4 out of 5 are sleepwalkers? And we look at this result here, we say that's about 3.5%. So we say the probability of x equal to 4, or the probability of getting exactly 4 sleepwalkers out of 5, according to the table, it is 0.35. So about 3.5%, right? Next, part B, find the probability of getting 4 or more sleepwalkers among 5. So that's asking what is P of x greater than equal to 4. Translate to this problem here, that is P of x equal to 4, exactly 4 sleepwalkers, or 5. So that's the addition rule, right, out of 5. And we won't go up to 6 because we only look at 5 adults. So we're looking at 0.035 plus 0.009 according to this here. So that will be 0.044. So about 4.4%. So 4 more. Okay. All right. So now the question asks, is it unlikely to get 4 sleepwalkers among 5 adults? Is it unlikely for us to go out there and say, hey, here's a group of 5 random adults? How is it unlikely to have all 4 out of 5 that are sleepwalkers? The answer is yes. Yes, it is unlikely to get 4 sleepwalkers among 5 random adults. Why? Because according to this here, because the probability of x equal to 4 is less than or equal to 5%. Right? We did that up here. Is 0.035. So 0.035 is less than or equal to 5%. So that's how you answer that question. Part D. So this question you may not see in the homework because I don't think the homework will ask this type of question because C is more fitting the way we ask question that fit the probability distribution. D is asking is 4 a significantly high number of sleepwalkers among 5 adults? And it said why or why not? Okay. So to answer this question, the answer is going to be yes for this one. All right. So this saying that it's not asking for probability, it's just asking is any, so among random 5 adults, getting 4 sleepwalkers out of 5, is that significantly high numbers of sleepwalkers? The answer is yes or no. So we're going to use range rule of thumb. To use range rule of thumb, we set up the boundary. So we said, all right, here's the mean. Here's 1, 2 standard deviation. Here's 1, 2 standard deviation below the mean. And then we're going to find the upper and lower value that separate the significant high and low value. So in this case, we're going to have, so mean is, then that requires to calculate the mean. Okay, so let's do that. Let's use our technology. So technology to find mean and sigma for probability distributions. Okay. All right, so we're gonna go ahead and go to here, stats, edit L1. The values was from 0 to 5, so 1, 2, 3, 4, 5, and then go over to L2. Let's clear out this data. So let's enter 0.166 according to the table, 0.37367, 0.298, 0.125, 0.035, 0.009. Okay. All right, so let's compute the mean and the standard deviations. Okay, so the mean is 1.523. The standard deviation is 1.07. So, all right, mean is 1.523. Standard deviation is 1.07. Okay, so let's go ahead and take 1.523 plus 2 times 1.07. See, what would that be? Okay, just calculate 1.523 plus 2 times 1.07. So that's about 3.663. So 3.663, that is the upper value for significantly, it's just that separate, so this value here, that separate from the not significant values to, significant high values. Okay. Later on, we're gonna introduce another formal name for these limit values, or this upper lower limit, where that value separate significant values from non-significant values, and we're gonna call that the critical value. So later on, we're gonna introduce the name. But in this case, 3.663 is the cutoff value. So is 4 a significantly high number of sleepwalkers among 5? The answer is yes, because it's past 2 standard deviations, right? So we say yes, x equal to 4, or 4 sleepwalkers among 5 random adults is a significant high value because it is more than 2 standard deviation above the mean. Okay. All right, so that's the last example I'm going to cover for this 5.1 video. I'll see you guys in the next video, which is 5.2.